Hello, everyone. Hello, lovelies. Welcome back. Yes, that was a hell of a hiatus, wasn't it? Yeah. But anyway, welcome back to this our legendary flagship series on my YouTube channel here, where we torture ourselves with C. Anyway, yeah, welcome back, you beautiful people. So I went off and I did a bit of research because obviously I need to still learn things as well, you know. And I've been preparing a bit of an expansion series on this on the flagship to my YouTube of this flagship series on my YouTube channel. Well, we're going to be doing some little programs, and first program that I want to kind of introduce to you, I guess, or make a tutorial from is stack. So we're going to be stack. We're going to be making data types and data structures in C. So that's what we're going to do today. So we're going to make a struct, and that struct is going to be a stack, and then we're going to do stuff with that stack. Yeah, we're going to just mess around with that stack a little bit and see what we can do, and we can also show ourselves how we can reverse a string using a stack. So that's interesting, isn't it? Okie dokie. That's the introduction done, obviously. Let us get into the coding. So, yep. So, I have here our tutorial program here where we do our tutorials in. And yeah, so let us get started. So first things first, we want to actually make a stack, and this could just simply be like an array or whatever. You know, I mean, you could just. Sorry, I'm yawning like a. That's rude. I'm sorry about that. I mean, sure, you could declare like an unsigned, unsigned char buffer right here, for example. For example, 100 depth of 100 or whatever, and then you could declare like a stack pointer. You know, that's gonna get very awkward because if we wanted to make functions for these, we're gonna have to pass these individually all the time. So this is just not very practical, and it's a waste of space. So instead, what I encourage you to do is to create a struct, and obviously the struct will hold this information. Will hold this information, and then we can just pass that struct into functions and manipulate that struct as sort of like a class in a way. So let us do that. So let us do the struct way. So what we want to do is we want to just go ahead and declare a struct. We're going to declare a struct, which is tag stack. This is the way I like declaring my structs. This is the way I do it. This is just how I like to do it. I've seen a lot of people say like, oh, well, like the way you initialize stacks, like, oh, it's whatever. Like, nah, all right? We go from largest to smallest, okay? That's the way it is. Do it that way. Don't make no excuses, okay? Largest to smallest, otherwise you'll confuse yourself. Just like why do people have to make things more harder for themselves if it's just so simple? Like, I don't get it. Like, just go from largest to smallest like a normal person. My God, it's just like, you know what I mean. So that's the way I'm gonna do it. I'm gonna go from largest to smallest because I want to keep track of my code properly. So the largest data type obviously would be a char pointer, would be our array of chars, aka a char pointer, and then we can just, and the lower one would be an int. So yeah, we can basically just do an unsigned char here. So for the people who don't know, I've seen a lot. I've even seen some people like being like, oh yeah, byte t or whatever, or word t. Hey man, I think we need to explain what byte is, right? And a short is. I think I need to make another video on that because people are still confused. Like, okay, to briefly explain, a byte t is just an unsigned char. Okay, that's a byte t, and a word, I believe, is an unsigned short. because char is 1 byte and short is 2 bytes. So if you don't know, a byte t is a unsigned char, which is 1 byte. And then a word t would be an unsigned short, which is 2 bytes. So you can store much data. You can store larger bits of data. Depends what you want to do. You can also have uint a t, which is a unsigned integer of 8 bytes. So it's an 8 bytes unsigned integer. It's an 8 byte, right? The length of 8 byte. So it's a 8-bit integer. Sorry, it's an 8-bit integer, which I think is an unsigned int. So it's the unsigned int. Uint 8 is just a standard unsigned int, right? And then you have like uint 16 would be long, I think. I don't know. There is a documentation page that you can look up. I'll probably leave a link in the description. You can go and check it out to see what each of these things mean. Let's get on with our little struct here. So, what do we want to do? So first things first, we have to actually sort of think about like what is the size of the data that we're going to store in here. Do we want to store small data like little bytes? Do we want to store something larger? If we just want to work with strings, we can just store a byte here. We can just store a byte and we can just cast signed, unsigned, whatever. You just have to remember. This one little thing. If you're casting from signed to unsigned or vice versa, especially from unsigned to signed, always make sure that a number exists in both unsigned and signed versions. Because unsigned you can go very large positive numbers, then if you put into a signed value will flip. So you need to be careful on that. Just, because they do overlap. Like you have numbers that exist in signed and in unsigned, but then the unsigned has a bit of an extension on the positive side, right? It extends. So just make sure that if you cast from unsigned to signed, you're not in the extension here, because otherwise it will flip and you'll get some weird negative number instead. So it's like, you have here and here, so you have numbers in signed and unsigned, and there's an overlap. But in an unsigned, you have an extension that goes beyond here that doesn't have a match in the signed version, right? So it will just flip and you'll get some weird like negative number. You'll basically overflow your signed integers, basically what I'm trying to say. So make sure that your casting makes sense, So in this case, I decided that I want to work with bytes, right? So this is bytes only. So while I work only in bytes, right? So I'm not going to be translating any of this to chars, right? To like signed chars, which is what the percentage C is. That's a signed char. Unsigned char is just a byte, just simply bytes, whatever, who cares? I'm not going to be translating these into chars. They're simply just going to be some byte values that I decide what they mean. For example, I give them my own meaning. And this is how we can form, this is, just forms a basis of every programming language, basically. But enough about that. Let's just move on. Let's get coding. So unsigned char, because I just want to make this a byte, so it's an unsigned char. And I just want to call this, let's say, a buffer. So it's a buffer for a stack. This buffer right here will hold the values. So maybe it's a bit counterintuitive, but I just want to call it a buffer. You can call it whatever you want. You can call it a dog or a cat or a bear for, if you like that sort of name. But I'll just go with the name buffer. Now I want to define a macro called max depth, which will be around 100. Just to make it a bit clear about what the number 100 means, because it's a magic constant, and we don't want to just have a random magic constants lying around. So, max depth right here. So basically, we've got max depth, and there we go. So this is basically our max depth. So it's 100 items in our buffer here, which is basically, it's whatever. This just contains 100 zeros as far we are concerned. Now we're going to get to the stack pointer. Now the stack pointer and stack length, the usable length that we are currently using, is gonna increase with the stack. So for example, I just want to make an integer. I just want to make and the length would be an unsigned int. So length in use, for example. And then I just want to make the stack pointer sp an integer. And the reason for that is because the sp works as like an index of sorts. Even though we don't really need the negative part, let's just make it an integer for the sake. So we go from the largest data type, which is the char pointer here, to int, which is 44. So this is a correct the way to declare a struct, and I'm not going to argue with anyone on that anymore. Okay, let's just continue. So now this is realistically all we really need. So our stack has a buffer that stores information, mainly bytes. Then it has a length that it has a variable that tells the user what length is currently being used of that stack, and we have a stack pointer, basically a little pointer like variable that always holds the index of the next value of an empty space. So it holds the index to where a value will be inserted, you know? So for example, if we insert two values, for example, at index of 0 and an index of, let's say, 1, so over here, for example, char, for example, stack pointer acts in a way. So stack pointer would be an int stack pointer. Basically, what stack pointer does, it points to the next free index in the stack. There we go. So it points to the next free index in the stack. So, for example, if buffer 0 is equal to 1, for example, because stack pointer is initialized to 0, right? So for example, if we assign something to this so this is going to be at 0, right? So we assign something at this index first, and then we increment the stack pointer. So for example, if we only have two values, let's say index 0 and 1, the stack pointer will point at the index 2. So then we can just insert something in there. I hope that makes sense. So now let's go type def. So let's do a type def for a struct here. So I want to name the struct tag stack to just stack, capital stack. I'm using the Windows convention here, not the Linux one. So capital stack, obviously. And then here I'm just gonna say, and here now we can actually start using our stack. So first things first, I'm not going to malloc this because that is stupid. All right, that's just dumb. Don't do that, because you're gonna be working with a struct pointer, and that's just gonna be an ass to deal with. You're gonna have to declare, instead of just a stack like this variable being allocated on stack, you're gonna have to make a pointer. So basically something like this, which this is just aids to deal with. So let's not do that. Instead, what I'm gonna do is I'm gonna do a memset here, and I'm just gonna pass in the pointer like this by reference. This is a much more cleaner way of doing it. So size of, let's say we can just do stack like this. So right here, this will basically zero out everything in our struct, including this entire array. So as you can see, if we let's say printf, so this is unsigned value, so unsigned digit, unsigned char, whatever. I want to print, let's say, stack dot buffer 0. So for example, this would be simply 0. So if we run this, this should just spit out 0. There we go. As you can see, there is a 0 there. So there is no like weird uninitialized spaces anywhere. So far we can check, for example, the stack pointer here, which should also be initialized to 0 as well. And as you can see, it indeed is initialized to 0, and then length in use, which should also spit out 0, and it indeed does. So now our struct is nicely, beautifully prepared to be worked with. So now what we can do is we can start shoving some crap into the stack, right? We can shove something into it at this point because it's ready. So we can start writing into it. So we have correctly declared a little struct that will hold our stack, and we correctly prepared our stack to be used. Now, all we need to do is just create a bunch of functions, sort of a helper functions, that will basically sort of help us work with this stack by just sort of passing in the struct itself. Yeah. So first function is a void, obviously. A void type called push. Obviously, makes sense. Like makes sense. This function makes obvious sense for obvious reasons. I'm sorry. So yeah, so push, where this function is going to be responsible for shoving a value into the stack. So all we have to do, but for this to work, we have to pass in the pointer to this struct by passing in it by reference like we did here. So what we need here is we actually need to request the memory address of this struct. If we don't do it, if this parameter is going to be without the pointer, what would happen is that we will create a copy of the struct here, and it actually would not affect anything. So let's do. So how does this work? Well, this works in a very particular way. We need to do we need to kind of like ask ourselves, like, is this struct being modified in this function? Yes, no. If no, you want to use the keyword const. If yes, you want to omit const. So is this struct being modified in this function? Yes, it is. So we don't use the word const. Do we need to pass in this struct by reference? Like, are we using this function to change something else, like some other variable, some other struct? Well, then we have to pass in it as a pointer. So we have to request a pointer. All right, good. So now with this information, we can actually start to put this. And this is a bit of a trick. Like, some people might want to put the type def here, but there's a problem. If that type def might not be defined, you might encounter a little bit of an issue. For example, if someone deletes this type def. So in here, in the parameters, you always want to use the struct's raw name here. You kind of want to avoid using like type defs, just to make sure that it will always work, you know? So let's do it. So what we need to do is we need to pass in struct tag stack. There we go. And we need to pass in the pointer. Okay. Now, is this pointer reassigned within the function? No. Therefore, we can safely put restrict there. And then let's just name our variable. So what is the name of our parameter? Well, this right here is called let's do a pointer to stack. So p stack right here. So we can have LP stack, so we can say long pointer to stack, but it's not long, so we just say, so we can just say p stack. So basically this parameter right here basically translates to pointer stack or pointer to stack. There we go. Easy peasy. So now what we want to do is we want to push this struct right here. So what stack do we want to push a value into? And this value, is it modified in any way within the function? No, so we can put const. Okay, and as you can see, we are using unsigned chars. So it's a const unsigned char, and let's see byte. Why see byte? To declare that this is a const parameter, so const byte. There we go. It makes it really clear what you're doing and what you're passing. So p stack, this is very obvious pointer to stack, and this is constant byte, you know? Simple, easy, nothing too complicated. So let's go. So let's see. So how do we actually do this? Well, we need to first insert the value into our buffer and then increment the stack pointer after we've inserted the value. So this function doesn't return anything. So all we need to do is simply say p stack, this little arrow because it's a pointer, and then here buffer, right? Okay, cool. Buffer. And then here we need to do p stack. So p stack sp. So right here. So I want to assign the c byte at the index pointed to by the stack pointer right here. So this is what we want to do. Now, what I want to do now is we need to increment the stack pointer, but how? So first, the stack pointer is pointing to a vacant slot in our buffer, which means that we insert the value first, increment after. Okay? Insert value first, increment after. That's why we put plus plus right here at the end. It's a unary operator, and we want to increment it postfix, right? So this is where we implement the postfix version of the unary operator plus plus, because we insert value first, increment after. So our stack pointer always points to a vacant part in our buffer. There we go. This one line of code is all that you really need to actually push a value into a buffer. Now, let's talk about two other functions. So there are two other functions called the top function and pop function. So these are another important functions to manipulate a stack. So obviously, let's talk about the pop function, because that one is a little bit difficult. That one is a little bit harder. So let's talk about that one. So we need to think about what this function actually returns. And it returns an unsigned char. So it returns unsigned char. It's not a pointer, you know? So remember, don't let the char don't let the char confuse you. Unsigned char just means I want to store a number that takes up 1 byte in memory. That's all a char is. It's nothing more, nothing less than that. Don't let it confuse you. Just because we use the word char when it comes to strings, it's nothing more than just I'm saying what I'm saying to the C program here is I'm saying I want to return a number that takes up 1 byte of space in my memory, which is from 0x0 to 0x, I think FF, right? 0xF, which is basically 0 to 256. Okay? Unsigned char 0 to 256. That's all you need to know. Let's just move on. So unsigned char goes from 0 to 256. Alright? And it takes up exactly 1 byte of memory in my program. Alright? That's all I want. So let's just go pop. There we go. So this pop function returns an unsigned char. And obviously we don't need to provide it. We only need one argument, and that is struct our stack restrict p stack. So we need a pointer to the stack, because this function is modifying the struct, therefore it needs to be a pointer. And then here we will basically return. So, oh, I forgot something really important in the push function. We need another line of code, and that is we need to increment length in use. So we need to increment length in use by 1. So that's another thing. So these two lines are important here. So what we want to do is basically we want to this length in use tells us the length of the struct basically. It tells us how much of our buffer are we using. So the valid indexes, or how long is our valid part of our buffer, you know? So here we want to basically return So here we want to do p stack and then length in use minus minus. So you want to decrement length in use, and then what we want to do is we want to return the last member that was inserted. So we want to return the latest data that was inserted into the buffer. So we do it like this. So we need to do buffer, and then here we need to basically return. Okay, so the reason, and we do a p stack and sp, obviously, obviously stack pointer, but this will actually return nothing or return 0, because what we are returning is we're basically pointing to an empty part in our the empty part. So this points to a vacant index. So there is nothing written in this part of the buffer in our stack. Basically in our stack there is nothing written when this pop function is called. This stack pointer right here is pointing to a vacant index where there is nothing, there's no data there. There is just a 0 there. So this is very useless. So we need to place the minus minus unary operator, either prefix or postfix, to kind of make sure that this works. Now, we are actually gonna use prefix, because if you are popping something out of a stack, the stack pointer is pointing to a vacant place in your stack. You need to reverse that pointer. You need to go one back. So reverse the pointer first, so it points to an actual value in your stack, and then pop that value out. And then a second time around, you reverse the pointer back and pop that value out. So that's where we're going to place minus minus right here. So this will make our stack operational. So good. Now we actually have somewhat of a stack simulation program here. We can write stuff to our stack, and we can remove data from our stack. Very useful. This is already kind of starting to take shape. Good. So now what we need to do is we just need the top function. The top function returns an unsigned char as well, and takes in the stack. But in this case right here, the top function actually is a bit different. It takes a bit of a different parameter. I just realized. I'm sorry. What this little function does, again, we need to ask ourselves, like, if I pass in the struct of our stack into this function, am I actually modifying the stack in any way? And observe how the answer to that question is no. We're actually not modifying it. So for this function, it would be perfectly acceptable to create a copy of our struct that only lives in the scope of this function, because we just want to read data from it, right? So it would be perfectly acceptable to basically say const, right? Because we're not actually we're not modifying our stack in any way with this function. Struct, let's just go tag stack, and then just say C stack right here. So C stack meaning constant stack, right? There we go. So this is all we need. So this one takes const struct, because we're not modifying this struct in any way. We're not modifying our stack with this function. So this is perfectly fine. Again, not modifying it, therefore passing a pointer to this function is completely pointless. It's pointless. Passing a pointer is pointless, guys. So I made a joke. Anyway, back to the point. Oh, it's pointless. Like, it's worthless. There's no need for us to pass a pointer here, since it's unnecessary. And if something's unnecessary, we don't do it. That simple. Yes, so this will basically just return C stack buffer and then C stack.sp. As you can see, observe how we're not actually changing anything with the stack pointer. That's because we actually want to do this right here. So actually, C stack right here. So is this It should be, is this being modified or not? I think this is being modified, yeah. My bad, so this is actually being modified, so we need to do it like this. Because we need to decrement stack pointer and then return that one. We will basically use the construct when we're just gonna print the values that we have. Okay, good. So now we have pop and top. Good. So now I'm gonna also give you one more bonus function. This bonus function, ooh, is gonna be basically just printing the valid data that we have in our stack, and this will take const stack. So yeah. Oops, sorry. Anyway, so here we have basically it doesn't return anything. I'm just gonna say print values. And here we'll take a const. A const struct tag stack c stack. Oh fuck. Oh Jesus. Oh nay. Okay, so I have stack here. There we go. And here I want to do C stack here. So what we want to do here is we want to print the valid values. This is actually super easy. We can just do this with one for loop. So int I equals to 0. I is less than C stack dot length in use. I plus plus. So the reason why it's in length in use is because this tells us how many indexes we have already written to. And we want to just print those. We don't need to print those like 95 zeros, you know, that are trailing after our data that's in there. Like, we don't need to write those. That's perfectly worthless. There's no need for that. So here I'm just going to say print, and then we want, as this is a byte, so 0x %x. And then here I want to say cstack.buffer. And then I'm gonna print I. There we go. So right here, this basically prints all the bytes that I saved in my buffer as hexadecimals, basically. So that's what we want. So now it's time to actually use our stack. So let's actually use this bloody thing, right? I mean, what did we program all of this for if we actually never ended up using it? So yeah, let's go. Let's use the bloody thing. How about that? So what I want to do, so let's say I want to push. As you can see, it takes the pointer to our struct, so we provided a pointer to our stack, and then a byte. I want a byte 0, so for example 0xa1. For example, this is the byte I want to push in there. Let me push another one. So 0xba, 0x, let's say 1. Good. And let me, okay, so good. So now I have these two values on my stack. Now I just want, now let's print my values. Now I just want to print my values. So I just do value and then add a new line there so it's a bit clearer. So now I just want to check. So I want to check whether these values are there. I can just use my print values function, which takes in a stack. So I can just provide in the stack. There we go. Now it has the stack, and then we can just print out. And as you can see, there we go. So we have these two values now in our stack. And as you can see, those two values were indeed printed out, 0xa1 and 0x1. Beautiful. Absolutely amazing. That is beautiful, isn't it? That's exactly the way it was intended. So let's say if I do like a push here, so I want to push, like, let's say another one, 0xff, for example. I would like to do 0xff, for example, and then print my values, and then, for example, I would like to pop, for example. So we can just ignore the return value completely if we wanted to. Stack, so I want to pop one from stack, and now I want to print my values, for example. So I want to print values stack. There we go. So I should now see that indeed, as you can see, it goes 0xa1 0xa1, and then 0xff, and then here it goes 0xa1, 0x1, and then the 0xff is gone. So as you can see, it indeed works exactly as we intended. Great, good. Okay, well, we can use this pop function to, for example, save it into a variable. So we can, for example, be like, I can, for example, oh, crappity poopity. Oh, so for example, here I can be like print value removed 0x%x, and then I can just say pop, and I'm gonna just pass in the struct by reference. There we go. So right here it will say which value we are removing. So as you can see right here, so where you always forget the new lines. Always forget the new lines. Every time. Cry every time. Okay, so as you can see right here, we have our three values that are printed. A1, 1ff. Then it says right here, the value removed is 0xff. And then here we have all the values without the 0xff. Now, top, for example, has a completely different approach. So value on top, and then I call top, for example, on the struct here. So we can just do it like this. And as you can see, if I run this, so instead it says a1 1ff, and it says value on top is ff. A1 1ff, as you can see. So it doesn't actually remove it. And the reason why ff is on the top is because we're putting stack into this. So this one is actually on the bottom. So the way you see it printed here is actually in like reverse order. So this is the one is on the bottom, this one is, and this one's on the top right here. Because a stack is like, you put stuff like this into it, right? So that's the thing. So it's just like basically inverting the stack like this and just shoving things up from above like that. That's basically what this does. It prints from the bottom up, basically. So A1 is on the bottom and FF is on the top. So this works exactly like intended. It works well. Good. And then, okay, good. I think that concludes this. Okay, good. If you made it through, well done. I think this concludes this video. I mean, I just wanted to show you how to make a basic stack, really. And I think this is very nice. It works really good. So yeah, hope you enjoyed it. I hope this was helpful. And yeah, I'll see you in the next one. In the next video, I have planned to do I'll show you how we can reverse a string in C using this stack method. It'll be fun. It'll be awesome. It's just one function. It'll just show you, it's like speedy demon. We're going to speed through that like never before. Everything will be fine. Life will be fine. Life will be beautiful again. Okay? So that's the next up in the C backlog of content. Yeah. So yeah, I hope you enjoyed. Oh wow, sorry about that. I smacked my knee. Anyway, I hope you enjoyed it. This video. I hope it was useful. I hope you found it helpful. If you found it helpful, always remember to just subscribe and like. You know, always helps out. And yeah, I'll see you in the next video. Goodbye.